Okay, chemistry, this is the homework for the percent yield. Okay, yesterday I gave you the notes for percent yield with the slides, and you only had one homework problem that I did so much of it for you at the beginning to try to get that one answer. And now the only other assignment you have the rest of this week is to do these 4 problems. And this is the end of this chapter. So next week we'll do some review, and then the last week of school, all you'll have is the study guide and the test, and then you'll be done. All right, so the first thing you have to do for these in number 1 is balance the equation. So we got to balance this. So let's do that together. We've got 1 carbon, 1 carbon. So that's all good. Oh, no, we don't. We got 2 carbons because we got 1 there and 1 there. So let's put a 2. Now we have 2 carbons on this side and 2 on this side. We've got 2 hydrogens here, but look, we've got 4 over here. So we better put a 2 here because 2 times 2 is 4. So now the hydrogens are balanced. The carbons are balanced because putting that 2 in front of the H2O didn't change our carbons. And that gave us 2 oxygens, which we have. So that is all balanced. Putting 2 coefficients, this one and this one, balances the equation for number 1. Then for part A, it says how many grams of methane, which is CH4, can be produced from 235 grams of carbon reacted in excess of water. Okay, you just don't have to worry about the water. So you're given this, you're given grams of carbon, and you want to find out how much methane, which is this, CH4. So you're going to change the grams of carbon that you're given, which is 235, to grams of methane. That's part A. Part B, and what that gives you in part A is your theoretical yield. Part B, they gave you your actual yield of 126. You're going to use your theoretical yield from part A and find your percent yield. So that's number 1. Number 2, same thing. We have to balance the equation. So let's see. We've got 1 nitrogen, 1 nitrogen. So that's all good. We got 3 hydrogens here, but we have 2 hydrogens over here. And then we got oxygens that are split. We have 2 oxygens. So what in the world are we going to do? Well, when I have a 3 and a 2, I usually go ahead and put a 3 here and a 2 there. Now we have 6 hydrogens, and that gave us 2 nitrogens. So we would have to put a 2 here to get 2 nitrogens. But what in the world did that do to our oxygens? That gave us 3, 4, 5 oxygens on this side, which there's no way we can get 5 oxygens on this side. So we're going to have to double everything so that we can make the oxygens an even number. So instead of a 2, let's put a 4. And instead of a 2, whoa, I did too much. Oh, let me go back to blue. Let's see, we had N, O, and instead of a 2 there, we're going to, oh, that's that. Oh, I'm sorry. We're going to put a 4, and instead of a 3 there, we're going to put a 6. So now look, over here on this side, we have 4 nitrogen, and over here on this side, we have 4 nitrogen. And over here on this side, we have 4 times 3, which is 12 hydrogen. And over here, we have 6 times 2, which is 12 hydrogen. So now all we have to worry about is our oxygen. We have 4 oxygen here and 6 oxygen, which gives us 10 oxygen. So now we can put a 5 in front of this, so we have 10 oxygen on this side. So this is your balanced equation for number 2. Your coefficients are 4, 5, 4, 6. And they can't be reduced at all. So you're going to do the same thing like you did in number 1. How many grams of water? So you're looking for this. Can be formed when 37.5 grams of NH3, this, reacts with an excess of oxygen. So you're going to start with 37.5 grams of NH3 and change it to grams of water. That's going to be your theoretical yield. Then in part B, you're going to find your percent yield because they're giving you the actual yield. All right, number 3, you can see I don't even have written down here because I don't need to help you with that at all. They gave you the actual yield. They gave you the theoretical yield. You just have to find the percent yield. That one is easy. Number 4, we have to balance this. So let's see, we have 1 beryllium, I think that is, 1 hydrogen, and 1 chlorine on this side. 1 beryllium, 2 chlorines, and 2 hydrogens. So it obviously is not balanced. So if we put a 2 in front of this, that gives us 2 hydrogen and 2 chlorine, and then we're all balanced. That's all we had to do to go ahead and balance it, is put that 1, 2 there. And it's going to be the same type of thing. It says the mass of beryllium chloride produced in the lab was 18.95. So that right there is your actual. What is the percent yield? If it was run with 245 grams of beryllium. So that's what you're starting with. And you're going to change it to moles, the grams to moles, and then you're going to change it to moles of what? What are you looking for? It told you beryllium chloride, which is this. So you're going to change the 2.5445 grams of beryllium to see how many grams of beryllium chloride that would make. And that's going to be your theoretical, and then your actual is given in the problem. So you can finish that. All right, those are your directions for this percent yield homework.